Biomimetic design is the art and science of creating materials inspired by nature's solutions. When we mimic nature at the molecular or structural level, we can create materials that are lighter, stronger, more efficient, and often far more sustainable than what we make using conventional methods. And to understand why this works so well, we need to look at the engineer behind these designs: nature itself. Nature is the ultimate engineer. Over 3.8 billion years, evolution has been running the most rigorous research and development program imaginable, testing countless designs, discarding what fails, and perfecting what works. The results are solutions that are highly efficient, often self-repairing, adaptable to change, and produced with minimal waste. In other words, nature's designs aren't just clever, they're optimized by time itself. And hidden within these time-tested designs are a set of principles that scientists and engineers now use as a guidebook. Most biomimetic materials share 4 core principles: hierarchical structures. Strength or flexibility comes from organization across multiple scales. Bone, for example, has nanoscale mineral crystals embedded in a protein matrix, arranged into fibers, which form larger patterns, each level adding strength and resilience. Multifunctionality. In nature, nothing serves only one purpose. Feathers provide insulation, help with flight, and display color for communication. Biomimetic materials aim to be just as versatile. Self-assembly and adaptability. Spider silk is spun at room temperature from water-based solutions, forming fibers that adapt to different needs. Sticky for catching prey, strong for structural support. Sustainability. Ecosystems build from abundant, safe ingredients and recycle everything. The goal is to design materials that are as environmentally responsible as they are high-performing. These principles come to life in remarkable ways when we look at specific examples where nature's genius has directly shaped human innovation. The lotus leaf inspired self-cleaning coatings. Its surface is covered with microscopic bumps that cause water to bead and roll off, carrying dirt away. The gecko's feet inspired reusable adhesives that can grip smooth glass yet leave no residue, thanks to millions of tiny hairs that exploit molecular forces. The layered nacre, or mother of pearl, inside seashells gave rise to ultra-tough ceramics. Its brick and mortar-like arrangement of platelets and proteins stops cracks from spreading. And the shark's skin, with its ribbed microtexture, inspired materials that reduce drag in water, improve swimming speeds, and even inhibit bacterial growth on surfaces. These ideas aren't just interesting, they're changing how we approach some of our biggest challenges. In medicine, bone-mimicking implants integrate better with the body, reducing rejection and speeding recovery. In energy, solar panels inspired by moth eyes capture more sunlight by minimizing reflections. In architecture, buildings modeled after termite mounds can regulate temperature naturally, cutting energy use dramatically. Recent breakthroughs are pushing biomimetic materials into exciting new territory. Self-healing materials can repair cracks and scratches, much like skin heals after injury, extending product life and reducing waste. Circular materials are designed for endless reuse, breaking down safely at the end of their life and reforming into something new, just as nature recycles fallen leaves into fresh growth. Stimuli-responsive materials can adapt on demand, changing color, stiffness, or permeability in response to heat, light, or mechanical stress. These advances hint at a future where our technology doesn't just coexist with nature, it works in harmony with it. Nature offers a masterclass in elegant, sustainable design. If we listen closely, the solutions to some of our most urgent challenges are already here. The future of materials science may be high-tech, but its roots are deeply, beautifully natural.